2 and 3. Today I will discuss about with you the internuclear axis. All of you still remember what is the internuclear axis? It is the line joining the nuclei of two atoms. Okay, M1 and M2. The mass of any two atoms. Here this line is joining nuclei of two atoms. We can say that it is the internuclear axis. Students, what is reduced mass of molecule? We already know that reduced mass of a molecule is M1 M2 divided by M1 plus M2, where M1 is the mass of atom 1, M2 is the mass of atom 2. Reduced mass is M1 M2 divided by M1 plus M2. Then comes to moment of inertia. Okay, what is moment of inertia? We generally define moment of inertia by the capital I, and I is equal to m into r square, where m is the mass of the molecule and r is the perpendicular distance. Then a moment of inertia I is equal to, it is the product of mass and square of the perpendicular distance from the axis of rotation. If we consider here the system, if we consider the moment of inertia for the molecular system, okay, then what will then my mass will be reduced by the mu, as mu is the mass of the molecule, and now the moment of inertia become I is equal to mu into r square. Okay, where r is the internuclear separation or internuclear distance. In some cases it also says that the bond length of the molecule. Okay, then comes to a question that here in the question the diagram is given for a molecular system. It is a molecule. A molecule consists of two mass, M1 and M2, mass of the atoms. Okay, and here x-axis, y-axis and z-axis, and the question is asked that this molecule will not show pure rotational spectra about which axis of rotation, Students, here it asked about which axis of rotation. To rotate the molecule we need the moment of inertia, and as we are seeing that y-axis is the internuclear axis. If I will take y-axis, which is the internuclear axis, in y-axis there will be no perpendicular distance. There is no perpendicular distance in which I can calculate the moment of inertia. So for this question the answer will be y-axis, because in y-axis moment of inertia will be 0. So the option will be y-axis, that is your option B. Okay, clear? Then comes to next one is we have also last week we have also calculated the energy eigenvalue of rotational motion. Remember by how we have calculated using Schrödinger equation. Okay, no need to remember you, but still I will remember you. What is Schrödinger equation? Nabla squared psi plus 8 pi squared. Remember how we have calculated 8 pi square? It is 2 mu h square e minus of v psi is equal to 0. Okay, 2 mu h cross square. What is h cross? H cross is h by 2 pi. Okay, h cross, where h is Planck's constant. Value of h is, you already know, 6.63 into 10 to the power minus 34 joule into second. Okay, we have all solved this type of equation and we finally reached the energy eigenvalue is Ej is equal to h square 8 pi square I j into j plus 1, where h is Planck's constant. The value of I is 3.141 and I is moment of inertia, j is rotational quantum number. Okay, the value of j is rotational quantum number. The value of j it rises from, it will from 0 say 0, 1, 2, 3 up to, we have taken up to infinity. Okay, if I replace the value of j is taken. If I take j equal to 0, then what will be Ej will be E naught equal to 0. Here you put the value of j is equal to 0. Okay, here 0 and here also 0, so the whole quantity becomes 0. When j equal to 0, then E naught equal to 0, means no rotation is present in the molecule. Okay, then rotational energy of molecule is quantized. The value of rotational energy is quantized by taking j or in terms of j. Okay, clear? Then comes to classical mechanics. The kinetic energy of rotation is given by E is equal to half I omega square. What is omega? Omega is angular velocity. What is I? Moment of inertia. Okay, and once again I will remind you, omega is v by r. We already know it. Okay, v is what? V is linear velocity. We can also say that v is equal to r multiple of omega. Just cross multiply, v is equal to r into omega. It is the general form. Okay, the linear velocity is equal to perpendicular distance into angular velocity. Here I have named all these equation. Okay, if I will name Ez equal to h square 8 pi square I j into j plus 1, this is equation number 3, and what is E is equal to half I omega square, it is equation number 4. Then if we will compare equation number 3 and 4, I can write half I omega square is equal to h square 8 pi square I j into j plus 1. Is the left hand side are equal, right hand side must be equal. From this equation you can calculate the value of omega square. Okay, to calculate the value of omega square, just cut it 284. Okay, and I will this side. Then now omega square is equal to h square 4 pi square I square j into j plus 1. Okay, this is the value of omega square. Then the value of omega, just take root of it. Then h square 4 pi square I square become h 2 pi by I root over of j into j plus 1. Okay, then another term I will calculate here, angular momentum of molecule. What is angular momentum of molecule? Here is equal to I into omega. Okay, I is moment of inertia. Put the value of omega from equation number 5. Here I take the value of omega, that is h into 2 pi I root over of j into j plus 1. I and I will cancel. What will remain? It will remain h by 2 pi I root over of j into j plus 1. So final value of angular momentum, that is L equal to h by 2 pi root over of j into j plus 1. Okay, do revise and practice more and more by writing, and we will discuss another topic on tomorrow. Remain healthy, be safe, and do practice more and more. Meet you tomorrow.